Question number 6, draw the skeletal formula. So you've got to draw the carbons in a line and not bother drawing the hydrogens at all. So you leave the hydrogens up from it. Draw the skeletal formula of propane. So that's 3 carbons, and you put them in little kink shapes and a little zigzag shape. 1,2-diol. So at carbon number 1 you've got an OH, and at carbon number 2 you've got an OH. So it's going to look like this: 1, 2, 3 carbons in a line, 1, 2, 3, and then an OH at carbon number 1, an OH at carbon number 2, and there's carbon number 3, and you've left off all the H's. You've not bothered drawing those in. That's the way that skeletal formula works. Write an equation for the oxidation of propane 1,2-diol under reflux, using O to represent the oxidizing agent. So propane 1,2-diol, so you can draw it now as a displayed formula with a C with 2 H's and no H, and a C with an H and no H, and a CH3 here now, an O to represent the oxidizing agent, and then it's going to form. Let's have a look what it forms. So this OH is a primary alcohol, so this is primary at the end because the C with the OH has got one other carbon attached to it, so the COH, one other carbon attached to it. This primary alcohol under reflux, so when you use an oxidizing agent, will first of all form an aldehyde group, a C double bond OH, and then that will oxidize again and form a carboxylic acid group. So you've got a carboxylic acid group here, a C double bond OOH. Before that, it's turned from a primary alcohol into an aldehyde and then into a carboxylic acid group. This OH here, however, is a secondary alcohol group because the carbon with the OH has got 2 carbons joined to it, 2 carbons bonded either side, and a secondary alcohol turns into a ketone, in other words a C double bond O in the middle of a chain, and that can't turn into a carboxylic acid. It would need to be on the end to turn into carboxylic acid. It would need to be an aldehyde to turn into a carboxylic acid, so that stays as a C double bond O ketone group. Now let's have a look. 3 carbons is okay. How many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, sorry, in this, 4 in this, and so we're going to need 2 H2O. It's going to form water. The O's remove the H's from here to make water, so we've got 4 H's. And therefore, if we've got 2 in front of the H2O to make 4 H's to balance up with the 4 H's here to make the 8 here, therefore we're going to have 1, 2, 3, 4, 5 oxygens needed. We've got 2 here. We're going to need 3 other oxygens here. Draw a label diagram to show a separate setup apparatus for refluxing. So you've got a flask, it'll need to be labelled. Then you've got a condenser. The idea of reflux is that you heat it, and then any gases that go up here then get condensed and drop down into the flask. So they get returned back into the flask because they cool here. The hot gases cool, condense back into a liquid and return back into a flask. It's a way of heating this liquid, these reactants, without losing them as vapours. You also need no gaps here as well, so you can see how it's drawn with the condenser coming down and maybe some kind of bung or something in here, but no gaps between the flask and the condenser, otherwise the gases would escape either side. Anti-bumping granules are placed in there. Why that? That's to prevent large bubbles from forming. Draw the structure of a different organic product formed when acidified potassium dichromate is not in excess. Well, not in excess, so the easiest one to show is that this would form an aldehyde group, and therefore it would stop at an aldehyde group if it's not in excess and would never form the carboxylic acid group. That's the easiest one to draw, where you've got a carboxylic acid group here, and this OH hasn't even turned into a ketone. So the carboxylic acid group hasn't formed, it's formed an aldehyde group here, and this one has stayed as an OH. You could say that one's turned into an aldehyde and this one's also turned into a ketone, but this one hasn't quite turned into a carboxylic acid group here. You could also say this one's turned into an aldehyde and a carboxylic acid group, but this one hasn't turned into a ketone group here, or you could keep this one as an OH and turn this into a ketone. So you can have any combination of aldehyde, carboxylic acid or ketone, but not forming the full carboxylic acid and ketone groups.